Tavapa Subsriber question number 3. The question reads, given that sine theta is equal to 5 over 13, express as a common fraction part 1 cos theta, part 2 tan theta. So what do we do here? Saka, we've been given that sine theta is equal to 5 over 13. Tikuda kutsvaga for part 1 with cos theta and gerichi. So we are going to employ this mnemonic CHASHOTAO. Saka CHASHOTAO inotiudza kuti sine theta inenge iri equal to opposite over hypotenuse. So we already know that a right angled triangle ndiyo inenge ina hypotenuse. Saka ngatise a right angled triangle panapa. This is our right angled triangle. Then our included angle theta-ish ngatitinde panapa. Saka for sine theta inofanirwa kuva opposite over hypotenuse. So this is going to be the opposite, and of course this is the hypotenuse. Saka tikatarisa sine theta being equal to 5 over 13, zvoreva kuti opposite yedu iri equal to 5 and hypotenuse yedu iri equal to 13, meaning kuti this is the triangle we are going to work with. This is the triangle we are working with, where the hypotenuse is 13 and this is 5, given that this is our included angle. Saka we now need to find x. Tikuda kutsvaga kuti that side rinenge richi. Kuti tiwane side rinenge richi, we are simply going to use the Pythagoras Theorem, which states that the hypotenuse squared is equal to a squared plus b squared, where a squared are either of these sides, kuti a uyu b uyu kana kuti a uyu b uyu. So a na b angora amwe ma sides, then we have the hypotenuse there. Kureva equal kuti, substituting into this equation, 13 squared is going to equal 5 squared plus x squared. What is 13 squared? Katuye kuno. Saka for 13 squared, it's just 13 multiplying 13. Saka here it's 0, 1 times 3 it's 3, 1 times 1 it's 1, 3 times 3 is 9, 3 times 1 is 3. Then if we add these, chat 0 plus 99, 3 plus 3 is 6, and here it's 1. Kureva kuti here it's 169. Then we already know that 5 times 5, which is 5 squared, into 25 plus x squared. So takuda manje subtract 25, because it's going to be 169 minus 25 is equal to x squared. So tikaya panapa tika subtract 25 panapa. Chat 9 minus 5 into 4. Because it's 5, 6, 7, 8, 9, 6 minus 2 into 4 zvakare. Then panapa 1. Saka 144 is equal to x squared. But tichiri panapa, let us erase these. We know kuti x achava equal to the square root of 144, which is equal to chi. It's 12, because 12 times 12 and panapa ndi 0, 1 times 2 ndi 2, 1 times 1 ndi 1, 2 times 2 ndi 4, and 2 times 1 ndi 2. Tikaeda, we are going to get 441. Tangoratidza kuti the square root of 144, taradza the square root of 144 ndi 12. So this is equal to 12. And kureva iko kuti panapa ndiyani ndi 12. Saka I wish kuti ma understand zvataita apa, because we need to erase the space to dzoka to solve our question. Saka this is our right angled triangle. this is the right angle, this is our included angle, this is our included angle theta, then here it's 5, the hypotenuse is 13, and here we got 12. What is next? Saka, we used sine theta is equals to 5 over 13 kuti tiite come up with this triangle. Takuchida ku answer this question. Part 1, cos theta. Kuti cos theta inge equal to chi. We already know from CHASHOTAO. CHASHOTAO kuti cos theta is equal to, tinotanga nekupesira inoi adjacent over the hypotenuse. Saka tikada kuita panapa, what is the adjacent? Saka adjacent panapa ndi 12 over our hypotenuse, it's what? It's 13. This will be what cos theta is. Question yedu yatoti express as a common fraction. Saka this is how we answer part 1. Part 2. Part 2 iri kuti iyo tan theta. So kuti wane tan theta, we are basically going to have two methods. So I'm going to start with the easier method and then go on to the, I'm going to start with the longer method. Inoshansa CHASHOTAO, then go on to a shortcut. Saka M1 zorot method 1. Saka method 1 yedu ichati chatarisa pa CHASHOTAO pedu panapa. Taona isusu kuti tan theta inenge iri opposite of adjacent. Kureva iko kuti tikatarisa pa triangle pedu panapa, relevant to theta, opposite yedu ndi 5, adjacent yedu ndi 12. So this is going to be our answer. But kana uri munhu understand trigonometry, you should know our method 2 kuti tan theta is equal to sin theta over cos theta. Saka we already know kuti sin theta yedu ndiani. Sin theta ndi 5 over 13. Then kuti sin theta over cos theta, zvongoreva kuti sin theta divided by cos theta. Saka divided by, what is our cos theta? Todzokera ku question yedu ishi. Our cos theta is 12 over 13 and 12 over 13. Then Pythagorean kana kuti multiplying by the reciprocal. Zvongoreva kuti kana tichida kubvisa this division sign, tichida kuisa multiplication sign, tichango Pythagora kunoku. Kureva tichaita 13 over 12. Then ma 13 ochekana. Then ma 13 ochekana. Kureva iko kuti 5 times 1 over 12 times 1. Saka answer yedu inenge iri 5 over 12. Saka tichi summarize the second part, maona kuti tikashandisa CHASHOTAO, it's just tan theta equal to opposite of adjacent, then directly answer yedu 5 over 12. Tikashandisa our knowledge kuti tan theta is equal to sin theta over cos theta, we can manipulate to one again 5 over 12. Let us go on to the part B of the question. The part B of our question reads, state the name of a polygon with rotational symmetry of order 3. Saka answer yedu panapa, it's an equilateral triangle. Triangle. Taziva sei kuti ndiyo answer. Chamufanira kuziva ndechekuti kana tine a regular shape, for a regular shape, number of sides is equal to the order of rotation. Saka an equilateral triangle, it's a triangle with 3 equal sides. Saka since it's a regular shape, the number of sides, which are 3 for an equilateral triangle, gives us the order of rotational symmetry. What does it mean with order of rotational symmetry? So we know kuti kana tine triangle yedu ishi, equilateral triangle yedu, kurati side iri ne side iri ne side iri zviri of the same length. Triangle iyi tinogona kuigura 3 times tichiwana ma equal halves. Kurati tikadai so panapa nepakati apa. Side iri neside iri zvakafanana, they are equal halves. Kora togona kuti pattern pakati apa. Saka this will be the first order of rotation. Tikadai so nepanapa. Side iri ne half iyi zvakafanana, togona kuti pattern over the second. Then tikadai so nepanapa. Again the same, this half and this half togona kuti pattern. So that is what we call a rotational symmetry of order 3. So that will conclude our question